On the other hand, if we, like the textbook, for whatever reason don't want to use p-values, we can instead work using what are called our critical values. Very similar language, very similar concept to the types of things we saw in Chapter 6 with the confidence intervals, where essentially instead of talking in terms of those p-values, we talk in terms of rejection regions, where the rejection region is essentially the area under our distribution where if the test statistic falls into it, if it falls into that range, we reject the null hypothesis. For somewhat obvious reasons, other textbooks will call this the critical region, and the rest of the distribution is called the non-critical or non-rejection region, where the obvious reason why it's called that is because the critical value is what breaks off the rejection region, or regions if it's a two-tailed test. So, if we want to think about this in a similar way, if we have a left-tailed test with alpha equals 1%, then we talk about the critical region or the rejection region as being what represents that alpha equals 1% specifically in the left tail, where the critical value for that, the value that breaks off that 1%, is a z-score of negative 2.33. If we want to do a right tail, you just flip it over and get positive 2.33. And then for a two-tailed test instead, if we want to get that value, we'd have to break alpha into two parts, one for each tail, where we'd get that half of the value if we make alpha equals 5 for a change of pace. We would get two z-scores with 2.5% on either side of each and 95% in the middle, where you'd get negative 1.96 and positive 1.96 as the two critical values breaking off that rejection and non-rejection region. Like I said a couple times now, I think 1.96 is a very important z-score for this and other reasons. But essentially, I'm talking about critical regions, rejection regions. It's different language, different process, different intermediate step towards the same idea, as we'll see next when we talk about the general testing process for the z-test using rejection regions and critical values instead of p-values.